In 2018, researchers studying bone fragments in Kazakhstan's Pavlodar region uncovered something that upended everything we thought we knew about this animal. The Siberian unicorn, long believed to have vanished around 350,000 years ago, had actually survived until just 39,000 years ago. It shared this land with Neanderthals. It stood on these plains as the first Homo sapiens moved into the steppe. And then, without warning, it was gone. The paradox, Elasmotherium was one of the most specialized herbivores ever to evolve. A rhino the weight of a small car, carrying a horn possibly 2 meters long, mounted on a bony dome at the center of its forehead. A creature so committed to the toughest grasses of the Eurasian steppe that its molars grew throughout its life, worn down, then replaced again and again. Yet every living rhino today is far more generalist. But the surprising thing is this: a creature so highly specialized was expected to dominate nature. Yet the reality was the opposite. It went extinct itself, while its less remarkable but more adaptable relatives survived. The breakthrough came from Pavel Kosintsev at the Russian Academy of Sciences Ural branch and Adrian Lister at London's Natural History Museum. Their team radiocarbon dated 23 Elasmotherium specimens from across the Eurasian steppe. The numbers shattered every assumption. Not 350,000 years, not 100,000. Some were barely 39,000 years old, recent enough for Neanderthal hunters to cross its tracks, recent enough for the first Homo sapiens entering Central Asia to watch it graze. And then, within a few millennia, it was gone. Elasmotherium's lineage stretches back roughly 2.5 million years to the early Pleistocene grasslands of Eurasia. Its ancestors were already giants. Elasmotherium caucasicum reached roughly 5 meters in length and weighed 5 tons, heavier than any rhino alive today. But the body was not the headline, the horn was. Unlike modern rhinos, which grow keratin horns on the snout, Elasmotherium grew its horn over a massive bony dome on the forehead. That dome was highly vascularized, feeding a horn of extreme size. Reconstructions range from 1 meter to more than 2. This was not a defensive display, not a sexual ornament. It had a job. The evidence we get from teeth. Elasmotherium's molars were hypsodont, extremely high-crowned, rooted deep enough to function as a lifetime grinding system. Jaw muscles anchored to buttresses thicker than in any other rhino. The neck vertebrae formed anchor points for driving the massive head downward. When Lister's team examined microwear under electron microscopy, the pattern matched grazing on abrasive, silica-loaded grasses of the Mammoth Steppe. Then came isotope studies. Nitrogen and carbon ratios in bone collagen pointed to a narrow diet, dry, open-ground grasses, not mixed browsing, not shrubs, not opportunistic switching, a specialist. And often, the papers end here, but the story doesn't. Because when the climate shifts, specialists have nowhere to go. To understand why Elasmotherium became this extreme, picture the world that shaped it. The Mammoth Steppe stretched from France to the Yukon, a cold, arid, grass-dominated biome that no longer exists on Earth. If you stood anywhere on that vast plain, grass ran to the horizon in every direction. For 2 million years, this ecosystem acted as a superhighway of coarse vegetation. Evolution rewarded commitment. A rhinoceros that fully committed to grazing, deeper molars, larger skulls built to process silica-rich grasses, could exploit a resource few other giants touched. The Mammoth Steppe was Elasmotherium's entire world. They rose together. They would fall together. The 2018 findings finally locked into place. Between 40,000 and 30,000 years ago, the climate destabilized. Cooling phases, broken by brief warm intervals, fractured the Mammoth Steppe. The grass did not vanish, it fragmented. The endless corridor that fed giants broke into scattered islands. For a generalist, survival was still possible. A woolly rhino could shift its diet. A horse could push further north. A saiga antelope could move 1,000 kilometers in a single generation. For Elasmotherium, every adaptation built over 2 million years became a trap. Its enormous molars were engineered for one diet. Its body demanded vast amounts of daily forage. Populations, already spread thin across immense distances, began to collapse into isolated pockets. Isolated, slow reproducing, incapable of switching. The last ones died somewhere in the Central Asian steppe, unseen, unrecorded. Today, only 5 species of rhinoceros remain. The white rhino grazes on grass. The black rhino feeds on leaves and shrubs. The Indian, Javan, and Sumatran rhinos are what's left of a lineage that once stretched across entire continents. None carries a horn on the forehead. None comes close to 5 tons. But watch a white rhinoceros drop its massive head and tear grass from the African savanna, and you're seeing the same evolutionary force that once shaped the Siberian unicorn. That pull toward grass, that quiet commitment to specialization. The blueprint never vanished. It shifted, smaller, more adaptable, and in that shift, it found a way to endure. The fossil record is full of puzzles waiting for detectives. Every week, this channel assembles another case from bone, rock, and radiocarbon, a mystery buried for thousands or millions of years. Subscribe, and the next one is already on the table. It was never really about the horn, never really about the rhino. It was always about specialization. And the question we're not asking, is it happening again, quietly, right now?